It's 3 o'clock.
Assalamualaikum dan salam sejahtera. Jumpa lagi kita pada kali ini. Kita akan bincang seperti yang dijanjikan tutorial 13. So tutorial 13 is gas law and theory kinetic. Kita sudah, saya harap semua sudah dapat soalan tutorial di Google Classroom, dan tadi pun saya dah bagi tugasan beberapa orang pelajar dan kita sudah dapat beberapa set jawapan. Jadi kamu boleh semak nanti ya. Sambil itu kita bincang beberapa soalan yang lain. Okay, so kita ada juga beberapa pelajar yang ada kelas dan ada juga pelajar yang duduk di kampung, dia punya talian internet dia tidak berapa bagus dan ada yang bagi tahu saya tadi mungkin tak boleh bersama-sama untuk sesi pada kali ini dan dia orang akan mungkin tengok lepas sini lah di channel YouTube macam biasa. Jadi saya rasa saya tak nak buang masa, terus kepada apa yang kita nak bincang hari ni tutorial 13. So boleh rujuk dekat tutorial, soalan tutorial Ini kamu sudah cuba dulu. This is tutorial 13. Sebelum tu ya, jangan lupa sila tulis nama dan kumpulan tutorial kamu di bahagian tepi tu sebagai kehadiran, bukti kehadiran kamu untuk sesi kelas pada hari ini. Okay, gas law and kinetic theory. So for the last week, I think we have already done for discuss lecture tutorial 13, gas law and kinetic theory, and we have already done for I think the past year question, beberapa soalan yang berkaitan. And today we try to discuss maybe not all the question for the tutorial 13, focus on the question yang saya sudah kongsi dengan kelas tadi dan dapat beberapa contoh jawapan yang dikongsi oleh pelajar-pelajar yang berkaitan. So first we go to the I look at the sample answer from the students. Okay, so this is the sample answer for student. I'm not sure this is come from the because tak ada nama kat sini tapi tak apalah, because untuk yang sesi ni just tengok pelajar ni akan apa jawapan dia dan apa dia punya reason yang dia bagi terhadap jawapan Okay, so first is because this is, I think this is question number 5 objective question number 5. Alright, I think you can see the question number 5 or slide question number 5. Okay, so number 5 is objective question. Ask you the degree of freedom of molecule is a number of, right? So degree of freedom is kita sudah bincang sebelum ini. Right, still just sorry. So we have okay. Okay. So So, degree of freedom, the symbol of degree of freedom, we use the F. So, degree of freedom, we focus on the three type of degree of freedom F. So, we focus on the mono, we have a di, and we have a poly, right? So, where is the, for the mono atom, a type of mono atom, so we have degree of freedom is a 3, for di we have a 5, and poly we have a 6. Betul kah? Okay, check balik yang kita ada. Okay, mono, di, poly. Right. So, but if you look at the question number 5, asks you to, it's about the degree of freedom of molecule number. This is more to the definition. So the answer, student give the answer is answer number C. A gas molecule execute transitional and vibrational motion. So for the, like say for the degree of freedoms, or we can refer to the reason why the student give the answer number C, because of molecule can absorb and release energy. Yeah, like say we have a system. This is a molecule gas or atom gas, and as we know, the theory kinetic of gases. Okay, we have the speed of the molecule gas bergerak secara rawat, random motion, and after collide with the barrier ataupun dinding kat sini, wall, dia akan reflect balik. So meaning we have a elastic collision, and dia punya direction tu tidak ada yang tetap, dia secara rawak, and dia punya shape, dia punya volume dia tu kita abaikan terlampau kecil. This is about the theory kinetic of gases. Lagi dia punya, kalau kita tengok kat sini untuk yang theory kinetic of gases ada beberapa ciri lah. You can refer to the lecture note. And kita tahu kalau dalam satu sistem itu merujuk kepada mono, di dan poly. For the mono atom, so we have the degree of freedom. Okay, if you refer to the axis, so we have y, z, and x axis. So we have 3 directions of the motion of the particle. So this is transitional, and but for the mono atom, so we have only transitional, or degree of freedom is 3. For di, so we have 3 for the transitional, and we have plus, this is come from the 3 transitional and plus 2 rotational. So, and for the polyatom, so we have 3 transitional and we have 3 rotational. So where is the 3, 5, and 6 come from is for the mono, di, and polyatom. We can use a value of the degree of freedom F. Okay, so now yes, because if you transfer heat to the system, so meaning here the atom or molecule gas can absorb energy, and dia akan menyerap tenaga, and dia akan bermula dengan lebih laju. So meaning bila dia serap tenaga, dia ada tenaga dalam, and molekul gas ni akan mula bergerak dengan lebih cepat. So meaning kalau dia bergerak, so we have absorb heat, and you have internal energy or U, and start moving, we have a kinetic energy, right? Okay, so now if you refer to the definition or degree of freedom, question number 5, yang sesuai yang kita nak dapatkan kat sini adalah melibatkan transitional and vibrational motion. Is referred to the degree of freedom depends of the type of atom or molecule, mono, di, or poly, right? So if you look at the answer number A, velocity component is needed to describe a motion completely. Velocity, no. For the theory kinetic of gases, the velocity, we not use the calculation. Velocity is normal calculation, so we have v is equal to distance divided by time t, right? So for the gas or theory kinetic of gases, velocity is referred to the V RMS yang kita sudah belajar ya, V root mean square, right? And lain kalau kita tengok internal energy component describe of total energy. So the total energy U, because we have energy is kinetic, transitional, kinetic, transitional. Also we have kinetic. Also we have a potential. But biasanya kalau kita rujuk kepada internal energy untuk yang atom gas ni dia merujuk kepada transitional kinetic energy. So the answer, the best answer for question number 5 is C. Okay, so the degree of freedom also occur in transitional and rotational motion. Ya, merujuk kepada jawapan nombor C lah kat sini ya. Okay. Okay, so this is question number 5. So meaning the number 5 you have a correct answer here, 5C. Number 5C. Okay, class. So continue to the next question. Kita tengok soalan yang lain dulu, selain daripada yang ni dibaca. So okay, so next question is I think this is yeah, also question, objective question. Right, so this is question number 1. So if you look at the question number 1, yeah, we have a graph. So question number 1, the situation attain containment sub steam is fused with cool water, as a result steam becomes contracted. So if you look at the situation given by the question, so you have the hot satu merujuk kepada satu sistem gas yang berada keadaan suhu yang panas, meaning we have a temperature here, and dia diletakkan next itu ke dalam cool water. So meaning here ada perubahan suhu. Let's say this is a T1 and the T2 and the change of temperature, and as a result the thing become contracted, meaning ada perubahan isi padu sini volume, right? Contracted maksudnya ada perubahan. So we have V initial or V1, okay, change to the V2, so meaning we have a decrease of volume here. So because the situation given by the question is referred to the temperature on volume. So as you know, gas law, so we already done for Boyle's law, okay, and we have the Charles law, and we have the Gay-Lussac law, Gay-Lussac law. So we have for the Boyle's law is referred to the pressure and volume, where the pressure is inversely proportional to the volume. And for the Charles, we have between volume and temperature is proportional. So meaning here, with the temperature, volume increase, temperature also increase. And for the Gay-Lussac law, the pressure and temperature also proportional P and T. So if you look at the situation number 1, this is a system for temperature and volume. So this is referred to the Charles law, right? So the Charles law, so meaning if you look at the graph here, so for the graph, because Charles law, volume is proportional to the temperature, or we can use the V1 over T1 is equal to V2 over T2. Okay, so here look the graph given by the question number A. So we have a straight line V versus T, and number B. So we also V versus T, but we have this is temperature is Kelvin, and this is temperature is degree Celsius, and this is P and 1 over V, okay, and PV. So saya rasa yang ni jelas. If you look at the relation between temperature and volume, or the Charles law is a constant volume, constant pressure P. So meaning here, V and T is proportional. So meaning we have a straight line graph. Itu kita tidak nafikan. Itu yang sudah dijelaskan dalam dalam nota pun jelas berkaitan untuk yang Charles law, Charles law. So semestinya when the V increase, T also increase. So the straight line. But the temperature here, if you look at the answer number A and number B, we have the TK. So kita tahu dalam case ini untuk yang gas law ni temperature kita pakai Kelvin Kelvin. Okay. But if you use the graph V versus T, so saya put ini dulu If you use the graph V versus T, yeah, we have a straight line graph because V proportional to the temperature T. But the T here is a Kelvin. But if you want to use a graph V versus T and this is temperature is Kelvin, if the T temperature is degree Celsius, the graph, yeah, straight line, but the value of the T here, dia tidak akan potong, dia akan potong di sini. So the T here is a negative 273, right? So relate the K for the 273 degrees Celsius is referred to the 0 Kelvin. So if you look at the answer, is correct answer is number 1 is A, right? So if you, if we refer to the, okay, yeah, answer given here is A, right? P, because when we talk about the Charles law, P is a constant. Kalau number C ni, P itu berubah ya, P itu berubah. Ini we have the change of V, okay, so yang C itu salah, okay. So ini juga menyatakan bahawa jasad itu, okay, bila perubahan suhu tu from high temperature to low temperature, what happen is the volume of the system is decrease, because perkaitan di antara temperature dengan volume kan. This is, let's say this is V1, this is a V2, let's say this is a T2. So this is change of volume here. So the change of volume here, but the pressure is constant. Tekanan itu tetap. Jadi untuk memastikan tekanan itu sama untuk dalam kes yang ini, P itu constant, volume dia tu terpaksa dikecilkan and the temperature decrease. Right? Okay, I think this is question number 1. Finish. Okay, so continue to the next question. So kita tengok lagi apa yang diberi oleh pelajar ya. Saya tak pasti. Okay, this is question number 6. Question number 6. So mungkin dia punya tuan dia tu boleh tengok question number 6. So apa itu? Okay, question number 6. This is a subjective question. Okay, so question number 6 is a tank has volume of 0.700 meter cube and contains 25. This is number of mole, this is volume, and this is temperature. Right? If the helium behave like ideal gas, so meaning here ideal gas theory itu dia menepati. Okay, so number 1 is number 6A is total transitional kinetic energy. So meaning here the question is straightforward because the value, because if you look at the value given by the question, so we have a volume, so we have a number of moles, so we have the temperature T. Because to calculate the total transitional kinetic energy, let's say we have kinetic energy transitional total, so we have equation 3/2 and RT, right? So this is the equation how you can calculate total transitional kinetic energy of molecule gas. And the value here for the number of mole N is 2.5, right? This is 2.5, and we have R is a molar gas constant. This is 8.31. Satunya soalan tu dia akan bagilah nilai-nilai exam, tak perlu akan menghafal. And the temperature is 10 degrees Celsius. So make sure lah if before you use the the value of temperature here, you must convert temperature in Kelvin. So how to change the 10 degrees Celsius to Kelvin is a plus 273, because 0 Kelvin is equal to negative 27 degree Celsius, right? So now for the temperature, if you use the temperature, this is a 273 plus 10, right? And you can find the value of the kinetic transitional kinetic energy of the molecule gas. The final answer is 8.82 exponent 3 joule, right? Okay, so kita boleh tengok apa yang diberi oleh pelajar tu. Kalau kita tengok sini, sorry. So, and question number 1, yeah, this is the straightforward. Okay, you can refer to the equation here, 3/2 nRT. So this is a number of mole. So this is constant R, 831. And so we have temperature. So the temperature here is Kelvin, right? And this is constant value of the R, molar gas constant. So we have 8818.99 joule, right? Or is equal to, use the answer given here is 8.82 exponent 3 joule, the same magnitude, right? So I think this is a straightforward to answer the question number 6A. So if you look at the question number 6B, so number 6B asks you to calculate this is average, average molecular kinetic energy. This is total transitional kinetic energy. So meaning here for the question number 6B, so also we have a equation, okay, average molecular kinetic energy. So the first for the total transitional kinetic energy, so we have a 3 NT RT. So average molecular kinetic energy, we use a 3/2 KT. So here we have this is K here is a Boltzmann. So we have a constant, Boltzmann constant. So we have a temperature here. So meaning kita boleh compare nanti bagaimana nilai-nilai ni yang boleh kita ni nanti. So if you to calculate the value here, so we have a 3/2, and the Boltzmann we have a 13, this is constant, 138 exponent minus 23, and we have the temperature, we have 283, right? So the final value of average molecular kinetic energy, so we have 5.86 exponent minus 21 joule. So the answer number A yang kita kira tadi kita dapat kalau tengok balik 8.823. Okay, so nilai ni kalau kita tengok dia terlampau kecil because of average molecular kinetic energy. So this is a transitional kinetic energy, merujuk pada tenaga dalaman yang melibatkan this kinetic energy pergerakan. So this is 862 exponent 3. So if you look at the answer, student answer, so yeah, so we have a kinetic. I'm not sure kalau kamu tengok dia punya simbol tu, so hati-hati, tapi simbol ni kita tak depend lah, because ada pelajar ataupun setengah-setengah buku dia gunakan simbol-simbol ada nilai E, okay, or K energy is depend. Tapi dalam exam kalau rumus ni dia bagi, so kamu kena pakai simbol yang dia bagilah, right? So senang untuk kalau pemeriksa untuk dapatkan kamu punya simbol yang betul. So this is 3/2 KT. So we have Boltzmann constant. So we have temperature. So we have 586 exponent minus 21 joule. So betul lah. Okay, seperti yang kita dapatkan tadi. Okay, kelas. So I think straightforward yang ni, tak ada masalah, rumus sahaja. So we go to the next question. Okay, so the next question is, this is question number 1. So number 1 objective question. So question number 1 is okay, look at the question number 1, right? So besarkan sedikit. So okay. Kita buang dulu yang di bawah ni dulu. Hydrogen gas thermometer is found have volume. So this is we have the volume when placed in ice water at 0. So we have initial temperature and we have initial volume. When the same thermometer immersed in boiling liquid chlorine, meaning we have the same thermometer, but boiling in liquid chlorine, boiling meaning we have a hot temperature. The volume of hydrogen at the same pressure is found 87.2. So meaning here this is initial temperature. When you increase the temperature, because boiling in liquid chlorine, so we have a volume, pressure is the same pressure, but the volume is 87.2 centimeter cube. Right? Calculate the temperature boiling point of chlorine. Okay, so for number 1, we can relate between okay, we can use equation. Gas law is a equation. We have PV is equal to nRT. Kamu saya rasa boleh juga penggunaan atau perkaitan di antara pressure and temperature. This is a Gay-Lussac law, pressure and temperature. Because dalam kes ini dia cuma buat perbandingan di antara dua situasi yang berbeza. Okay, same thermometer tapi pada situasi yang berbeza dan melibatkan perubahan isi padu kat sini. Okay. So untuk yang pertama tu, kalau kita tengok dia menggunakan situasi yang ada adalah pressure. So kalau kita ada kat sini, let's say this is initial, saya buat initial kat sini, P initial, and this is V initial. Okay, so this is constant, R is constant, and so we have a temperature, let's say initial temperature. Okay, the second situation, let's say this is a first situation. The second situation, kita masukkan dalam sistem yang kedua ni. Okay, let's say this is a pressure 2, V2, and let's say this change of temperature or T2, right? So dalam kes ini, kalau kita tengok same pressure, so meaning here, so we have a constant value of the pressure, P yang tidak berubah, N pun sama, and R pun kalau kita tengok kat sini, apa jadi? R pun constant kan, tidak berubah. So meaning here, apa yang berubah sini merujuk kepada volume and temperature. So kalau kita ambilkan dua situasi ni, so kita boleh ringkaskan kat sini perkaitan di antara temperature dengan volume. Ataupun first situation, second situation, okay, kalau kita bahagikan dia ataupun kalau kita samakan dia, so kita akan dapat T1 over V1. This is equal to T2 V2. Ini macam yang Charles law perkaitan kat sini. So meaning here for the question here, what is the temperature boiling point of chlorine, right? So sama dengan boiling point chlorine itu sama dengan temperature untuk yang thermometer lah, thermometer hydrogen thermometer yang sama. Right? So this is what is the value of the T2. So the T2 here, so you can use the equation here. T2 is a T1 V2 over V1. So the T1 is 0. So 0 meaning we have a change to the Kelvin is 273. And the V2 we have a 87. Sorry. 87. 7.2 centimeter cube. Okay, so V1, so we have 100. This is initial. So centimeter, so kita boleh cancel kat sini kan. So the final temperature T2 is equal to 238 Kelvin. Right? So ini yang kalau kita tengok sini lah. Bagaimana kalau jawapan pelajar? Kita tengok. Okay, so this is question from students. So first tengok sini. Okay, dia tukar dulu temperature. So we have a initial pressure, initial volume, and initial and number of mole. And this is initial temperature. And the next situation is boiling liquid or final here. So, kita panaskan dia lah. Okay, dia punya pressure tu the same pressure, tak berubah, tapi volume dia tadi berubah, right? From 100 to 87, and N is the same, kon tidak berubah. And what is the value of temperature 2? So here, use the equation here. Okay, PV and NRT. Okay, so ini yang pertama. And we have a P1, V1 is equal to N2 RT2. So kita samakan dua ini, barulah kita akan dapat yang persamaan di bawah sini. Okay, saya terangkan tadi ya. So the next you can find the value of the temperature 2. Itu kita gantikan sajalah. So 238. Samalah jawapan tadi kan. Cuma kat sini dia tak tunjuk perkaitan. This is dia ada ke atas tadi. Dia ada tunjuk tak tunjuk dekat sini ya. So meaning here you can, patutnya kat sini kamu kena jelaskan lah. This is P1. P1 is equal to NRT1. So kita lirik yang di bawah tadi. Okay class. So this is question. So kita tengok the next question lagi. Okay. This is question number 4. So what is the question number 4? Okay, number 4 is about the RMS, root mean square. VRMS, sorry. Okay, so kita tahu dalam satu sistem, gas system, so the speed of the atom molecule we can refer to the VRMS, root mean square. So we have the equation to calculate the VRMS, yang mana kalau kita tengok dalam, kita tengok sebelum ni ya, dalam nota ataupun dalam mana-mana rujukan, kita ada beberapa perkaitan di antara untuk yang VRMS itu. So kita ada perkaitan dengan temperature, so we can refer to the VRMS is equal to 3RT over M. So R is a molar gas and constant, so T is temperature, and the big M here is a molar mass of gas. So meaning here, because of R and M is constant, right? Constant. So VRMS here is depend on the value of the temperature. So meaning VRMS is proportional to the temperature. Logic kan? Because if you increase the temperature, here, so meaning we have a extra internal energy of the molecule gas. So meaning the speed ataupun dia bergerak dengan lebih laju. Right? So meaning here, if the temperature increase, VRMS also increase. Right? Okay. So also we can refer to the equation for the VRMS with pressure P. Yeah? So we can refer to the VRMS to the pressure P, or we can refer to the density rho. Kalau kamu ingat persamaan yang ada yang kita bincang minggu lepas tu, PV is equal to 1/3, and the big M here is referred to the number of molecule. Okay, the small m here is referred to the mass of molecule gas, the small m. And so we have a V square. So apa itu V square kat sini? So V square kat sini adalah mean square velocity. So this is a volume, so this is the pressure. So maksudnya kamu kena banyak nak tahu perkaitan, maksudnya bukan single rumus sahajalah untuk menyelesaikan soalan sini. Mungkin ada beberapa cara. Right? So bergantung kepada maklumat yang diberi. So because kalau kamu tengok soalan question number 4, the information, we have a temperature and we have a RMS, RMS speed, right? So jadi kalau kita nak kaitkan kat sini, di mana VRMS? Ya, kita ada satu perkaitan lagi. VRMS juga dia ada kaitan dengan apa? Dengan mean square ataupun mean square velocity. So mean square velocity, so how we can relate to the VRMS? Okay, VRMS kat sini kita boleh kaitkan dia, di mana VRMS itu adalah sama dengan apa? Perkaitan di antara VRMS itu dengan mean square velocity. Perkaitan di antara sini. So kita boleh kaitkan kan, because yang mean square velocity dengan VRMS ni, bila kita boleh kaitkan dengan V kat sini, so kita boleh kaitkan dengan perkaitan bersama ni lah. Right? So kalau kamu tengok dalam nota tu, dia ada beberapa rumus ataupun yang berkaitan kat sini lah. Ataupun juga kita boleh kaitkan juga dengan VRMS to the temperature, but we use Boltzmann constant, iaitu 3 kT over m. And this is K Boltzmann, and we have the small m here is a mass of molecule. So depend lah. Okay, so balik dalam persamaan, question number 4. So here, what is the temperature? Okay, jikalau okay, saya potong sini balik. Question number 4. So question asks you to calculate the find the temperature RMS speed of helium molecule 1.3 times greater than RMS speed at temperature 310 Kelvin. So meaning here, the information we have temperature and value of the RMS speed, right? So meaning you can use because the temperature VRMS is equal to 3 RT over M. Okay, so for the temperature 310, okay, this is temperature for the 310, because we have a 310. Okay, this is let's say for the VRMS of first situation. Okay, so the second situation, so let's say we use VRMS2, the second where the temperature change, perubahan suhu berlaku yang kita nak cari tu. Let's say this is the T2. So we have VRMS2. Also we have the same equation 3RT. So but T here is a T2 lah, right? But the value of the R and M is same, tidak berubah. Okay, so kalau kita ambil dua persamaan ini, so meaning here, so we have a VRMS2 divided by VRMS1 is equal to, so VRMS2, so we have VRMS2, so we have 3RT2. Okay, this is over M. So here we have 3 1 RT1 over M. So meaning here we have the same magnitude for the RM, so meaning we can cancel. Also the 3 is the same, so meaning we can cancel here. So ini matematik perkaitan kat sini. So we have VRMS2 divided by VRMS1, okay, is equal to, tinggal cuma T saja kan. So T2 over T1. So now the question asks you to calculate the T2. So VRMS, dia tak bagi nilai kat sini kan, tapi dia kata VRMS speed of helium is 1.3 greater than RMS speed at temperature. So meaning here, for the VRMS2 here, is 1.3 VRMS1. So we can cancel VRMS1. So now because the T1 here is 310 310. So you can find the value of the T2. So the T2 here, the calculator, this is 3 rho 1.3. So we have 524 Kelvin. Right. Ataupun kalau lah, because kalau kamu sudah biasa soalan sini ya, untuk lebih cepat ya, jadi boleh teruslah, because kita dah tahu tadi V is proportional to the temperature T ya. Dia berkadar terus ya. Right? So that's why we can use the VRMS here. So this is not volume, this is VRMS, sorry, RMS. VRMS, okay, VRMS2, VRMS1 is equal to T2 over T1. Tapi macam mana benda ni dapat, sebenarnya hasil kita bincang tadi lah. Tapi untuk cepat kita boleh terus guna ini pun boleh juga. Okay, kita tengok contoh jawapan yang diberi oleh pelajar. Tidak tahu siapa pelajar ni so kita tengok. So, okay, yes, dia guna persamaan sini. Jangan lupa dalam exam ya, kena tulis rumus ni. So first temperature 310 310, and the second temperature, so kita nak cari, and this is the value of the VRMS dia. Okay, so dia gantikan, so ya ada konsep yang kita lebih kurang sama juga tadi. So kita samakan dia, VRMS2 divided by T2 T1. Okay, next. Okay. Okay, saya ingat sini ada sikit because kamu tak boleh cancel, because sini kamu tulis VRMS2, this is VRMS1, tak boleh kamu cancel. Sebenarnya this is not 2, this is 1 baru kita boleh cancel. Barulah kita boleh cari T2 ya. Jawapan tu salah betul cuma sini saja salah because kalau kita tengok sini dia macam VRMS2 VRMS1. Macam mana kamu boleh cancel? Tak boleh So label tu betul because sini merujuk kepada VRMS1. Also here we have VRMS1. So barulah kita boleh cancel. Okay. Boleh. So tu saya rasa yang next. Okay. So habis ini antara yang saya ambil So saya ingat ada lagi lebih kurang 15 minit, kita tengok beberapa soalan lagi Okay. Okay, kita tengok yang question number, let's say question number 10 Okay. So question number 10 boleh tengok question number 10. So here we have a question about the internal energy. Right? Calculate internal energy of 4 mole polyatomic at temperature 12 degrees Celsius. Now, so how to calculate this is 10A. So we have equation for internal energy, U is equal to, so can use the U is equal to F over 2 and RT, right? So this is equation to calculate the internal energy, and the value of the, okay, N is 4 mole, 4, this is 4, and R is constant 8.31, and temperature here is 12 degrees Celsius. Must change to the Kelvin is so 12 plus 273 and what is the F with a degree of freedom. So we have a poly. So poly means degree of freedom is 6, right? And you can find the value of the U here is 2842.2 joule, right? Number 10A. And number 10B is calculate the change internal energy for 3 mole hydrogen is heated from 273 and 3 Kelvin. So meaning here we have increased the temperature. So meaning change of the internal energy because we have change of temperature. So meaning here you must find the value of the initial initial energy and compare to the final initial, let's say, yeah, U2. Or you can use equation U, because U internal energy. So this is hydrogen, hydrogen gas. Hydrogen, we have degree of freedom is a diatomic gas, so degree of freedom. So we can set the formula here, F over 2 and RT. Okay, for the hydrogen, so degree of freedom is a 2. And N, so tak tahu, tidak bagi. Okay, adakah? Oh sorry, 3 mole. This is 3. And we have R is a 8.31 constant, and temperature we have initial 273 and final 323 Kelvin. So you can use the, here we have a delta U here, so ini sama, yang ni sama. Okay, yang tak sama cuma temperature saja. So meaning here, so we can use a 5 over 2 times 3 mole, so constant R and temperature is changed, right? So we have a final minus initial, right? So final we have a 323 and initial we have a 273. So you can use the calculator here. So the change of internal energy is a 3116.25 joule. Tapi ini salah satu cara lah. Okay, yang saya tunjuk kat sini salah satu cara. Mungkin ada cara yang lain, bergantung satu maklumat yang dia bagi, yang keduanya rumus yang kamu pakai. Right? Okay, question number 10. So kita pergi lagi. Okay, soalan-soalan yang lain kita tengok yang kita tak bincang. Okay, I think the question number 5. Okay, look at the question number 5. Okay, number 5A, we have RMS speed of atom. This is atom monoatomic. Temperature 20 degrees Celsius is 203 meter per second. Find mass of atom. Okay, so kalau kita tengok kepada soalan sini, objektif kamu sekarang ni kamu nak cari dia punya mass of atom, or this is the M, small m, mass of atom. So because dia ada kaitan dengan RMS, so kamu kena pastilah macam mana perkaitan mass of atom dengan VRMS. Ya, seperti yang saya rasa kita bincang tadi, kita ada perkaitan atau persamaan VRMS. We can relate to the mass of an atom by using the equation VRMS is equal to 3 kT over m. So we have a small m here, mass of an atom. So now you can refer to the information given by the equation with temperature here. Because the temperature is in degrees Celsius, so you must change to the Kelvin is 20 plus 273, and the K is Boltzmann. Boltzmann is constant, 1.38 exponent minus 23, and VRMS is 603, 603. So meaning you can find the value of the mass of atom. So you can use the calculator here, because all the value here is 3.336, 36 exponent minus 626 kilogram. Right, so meaning here kamu kena tentukan apa yang objektif yang kamu nak cari and tentukan perkaitan sesuai. Because kalau kamu pakai VRMS is equal to, okay, apa yang satu perkaitan yang kamu boleh pakai yang VRMS itu, kita boleh pakai apa? 3 RT over M. Boleh juga yang ni because kamu boleh pecahkan M ni kat sini kan. Tapi dalam kes ni mungkin dia tak bagi molar mass dan sebagainya suatu hal. So yang ni straightforward lah. Okay. Ataupun we can use perkaitan VRMS tu dengan pressure ataupun density rho. Okay. Itu pun bergantung lah. Tapi tak perlulah kita mencari jalan susah because kita dah ada rumus yang ini. The straightforward. Right. So, question number 5B. So number 5B, calculate root mean square speed of oxygen molecule at 300 Kelvin. So tujuan kamu kat sini adalah untuk mencari dia punya VRMS. So what is the VRMS? But the information is a temperature. So what is the best formula to calculate the VRMS yang mana kita boleh cari bila dia bagi temperature? So kita boleh gunakan 3RT over M. Also you can use 3 okay, T yang tadi okay, T over M. Tapi dalam kes ini dia dah bagi apa? Molar mass. So semestinya lah kita guna yang inilah. So senang. So we have this is R constant, temperature berapa? 300 and molar mass we have 32. But make sure ya dia punya 32 ni dalam unit apa? Gram per mol. Okay. So dia punya unit-unit tu perlu dalam standard ataupun perlu kita gunakan SI unit. Okay. So now masukkan saja nilai kat situ. So kita boleh dapatkan dia punya nilai VRMS kat sini lah. Okay. Nilai R, nilai T sudah ada. This is 300 R constant 831. Okay. Molar mol gas ingat ya, dia bagi sini 32 This is gram per mol. Because kita pakai the final answer is a standard, so mesti kita 32 ni kamu kena bahagikan dengan 1000 kan, tukar kepada kilogram. So the final answer VRMS is a 483.44 meter per second. Right? So mungkin ada cara lain mungkin ini boleh guna, yang ini pun boleh guna juga, tapi bergantunglah kepada maklumat yang dia bagi dalam soalan. Okay kelas, so kita dah sangat banyak beberapa soalan, ada yang satu dua lagi soalan yang kita tak bincang tu, saya rasa kamu boleh cubalah. Okay sendiri, kalau ada masalah nanti boleh tanyalah. So hampir 1 jam So jadi untuk hari ini saya rasa sampai di sini saja kita punya kita punya kelas kita. Nanti the next mungkin besok besok kita akan masuk chapter yang terbaru, chapter terbaru dan terakhir chapter 14. Okay, thermodynamic. Right, so apa pun nanti saya akan bagi tahu dekat group nantilah. Okay, so sekali lagi yang soalan-soalan yang belum kita bincang tu kamu boleh cuba dulu sebagai untuk revision and tengok soalan-soalan pasir yang kita, actually soalan pasir itu sudah bincang beberapa soalan sebagai latihan So I think that's all for today. Thank you kerana sama-sama untuk hadir pada hari ini. Okay, saya ucapkan banyak terima kasih. Kita jumpa esok untuk new chapter and the last chapter for the first semester. That's all. Thank you. Assalamualaikum dan salam sejahtera.